Find the mean of the data in the bar chart below. Okay, so we have a chart that represents puppets made by each puppeteer. On the y-axis we have the number of puppets, on the x-axis we have the names of the puppeteers, and now we have to find the mean number of puppets. Okay, so Alex made 1 puppet, Kaylin made 4 puppets, Bruce made 3 puppets, and Davi made 2 puppets. So we add them all up and we divide by the number of puppeteers. So we have 4 puppeteers. 1 plus 4 is 5, 5 plus 3 is 8, 8 plus 2 is 10. 10 divided by 4 is 4 goes into 10 2 times, and we have a remainder of 2 over 4, which is 1/2. So 2 and 1/2, or 2.5, is the mean number of puppets that each puppeteer made. Let's see if this is the correct answer. 2.5. Yes. Good. Next question. The following table shows last year's revenue for each Herman's Hoagie's location. Okay, location and revenue. Cedarton 121, Rimber 189, Linton 147, and Granton unknown. If the mean of the dataset is $158,000, find the revenue for the Granton location. So we don't know the Granton location revenue, but we do know the mean of all the locations. So, okay, so 121 plus 189 plus 147 plus an unknown number, let's call it x, divided by the number of locations, which is 1, 2, 3, 4 locations, we have a mean of 158. Okay, now we have to isolate the x. So the first thing we do, we multiply both sides of the equation by 4 to get rid of the denominator. So 121 plus 189 plus 147 plus x equals 158 times 4, and here divided by 4 times 4, so 4 cancels 4, so we are left with 121 plus 189 plus 147 plus x equals 158 times 4 is 158 times 4. 4 times 8 is 32. 4 times 5 is 20, plus 3 is 23. 4 times 1 is 4, plus 2 is 6. So on the right hand side we have 632, and now we have to add all these numbers. 121 plus 189 plus 147 equals 1 plus 9 is 10, 10 plus 7 is 17, 1 plus 2 is 3, 3 plus 8 is 11, 11 plus 4 is 15, 1 plus 2, 3, 3 plus 8, 11, 11 plus 4 is 15, 1 plus 1 is 2, 2 plus 1 is 1, 2, 3, 4. Okay, we have 4 here. So on the left hand side of the equation we have 457 plus x right hand side of the equation we have 632. Now to isolate the x, we subtract 457 from both sides of the equation. So on the left hand side we are left with only x, and on the right hand side we subtract 457 from 632. So x equals 632 minus 457. Okay, we need to, okay, 6 becomes 5 and 3 becomes 13. And 13 becomes 12 and 2 becomes 12. Okay, 12 minus 7 is 5, 12 minus 5 is 7, and 5 minus 4 is 1. Let's see that this is correct. 175 plus 4, 5, 7. 5 plus 7 is 12. 1 plus 7 is 8. 8 plus 5 is 13. 2 plus 4 is 6. Yes, okay. So 332 minus 457 equals 175, which means that the revenue for the Granton location is $175,000. Let's see if this is the correct answer. 175. Good. Let's move on to the next question. Okay. A cat gave birth to 4 kittens. 3 of the kittens had different masses between 147 and 159 grams, and 1 kitten had a mass of 57 grams. Okay. The kitten that had a mass of 57 was then adopted, so that kitten was removed from the data set. How will the removal of the kitten affect the mean and the median? Okay, so for the mean, it's obvious that when we remove 57, it will cause the mean to increase. So the mean will definitely increase, because when we because when we take into consideration 57 grams as a part of the data set and it's lower than the other the masses of the mass of the other kittens, it means that the mean will go up. As for the median, okay, let's say that we have 57 here and we have 147 and 159, and okay, we have 3 kittens between 147 and 159. Okay, so let's say, just for example, that the third kitten has a mass of 149. So to begin with, we have 4 data points, and the median is the mean of these 2 data points, because these are the 2 numbers in the middle. We have an even number of data points, so we don't have 1 number in the middle, we have 2, and we have to find the mean of these 2 numbers. And the mean of these 2 numbers is 148. And if we remove 57 from the data set, then we are left with 3 numbers. Okay, so the median will also increase in this instance. It will become 149 because this will become the middle number, so this will be the median. So the median will increase as well from 148 to 149, but I guess the median will increase by less than the mean. The mean will increase more significantly than the median. Okay, let's see the answers. Both the mean and the median will increase, but the median will increase by more than the median. No. Let's just calculate the mean for my example. Okay, so the mean, if we do take into consideration 57 plus 147 plus 149 and 159 divided by 4. Okay, so 57 plus 147 plus 149 plus 159. 7 plus 7 is 14. 14 plus 9 is 23. 23 plus 9 is 32. 3 plus 5 is 8. 8 plus 4 is 12. 12 plus 4 is 16. 16 plus 5 is 21. 2 plus 1 is 3. 3 plus 1 is 4. 4 plus 1 is 5. So we have 512 over 4, which means that the mean is 4 goes into 5 one time. 1 times 4 is 4. 5 minus 4 is 1. 3 times 1, we have 11. 4 goes into 11 2 times. 2 times 4 is 8. We have a remainder of 3. And we bring down the 2, and 4 goes into 32 exactly 8 times with no remainder. So the mean is 128. If we take into consideration the 57, the mass of the fourth kitten. But when we eliminate this data point from the data set and we are left with only 147, 149 and 159, then the mean will increase by a significant amount. It will be somewhere between 147 and 159, and it means that it will increase significantly more compared to the median, which we saw that it increased by 1. Okay, so both the mean and the median will increase, but the mean will increase by more than the median. That's the correct answer. Okay, so let's copy first copy the question to the board. Find the median of the data in the pictograph below. Each symbol of a ball equals 2 balls. Okay, let's check the pictograph. Rubber balls, each dog has rubber balls, and these are the names of the dogs, right? Yes. Okay, and each symbol here equals 2 balls. And we need to find the median of the data in the pictograph below. Okay, so Bella has 1, 2, 3, 4, 5. She has 10 balls because each ball here represents 2 balls. Max has 1, 2, 3, 4, 5, 10 balls as well. Daisy has 1, 2, 4 balls, and Buddy has 2 balls. Okay, so let's order them from least to greatest. 2, 4, 10, and 10. So we have 4 data points, and the median, we need to find the mean between the 2 middle numbers, because we don't have an odd number of data points, we have an even number of data points, so 4 and 10 are the 2 middle numbers. So we have to find the mean of these 2 data points. Okay, so 4 plus 10 is 14. 14 divided by 2 is 7. So 7 is the median number of balls. Let's see if I'm correct. 7. Good. A group of 4 friends like to bowl together, and each friend keeps track of his all-time highest score in a single game. Their high scores are all between 180, and we have 4 friends, 180 and 220. Except for Adam, whose high score is 250. Okay, so we have an unknown high score for the third friend. We have 1, 2, 3 friends, and we have a total of 4 friends, so we don't know the score for the third friend. And this is Adam. Okay. Adam then bowls a great game and has a new high score of 290. So now the question is, how will increasing Adam's high score affect the mean and the median? Okay, so of course, when we shift Adam's high score to the right on the number line, it will cause the mean to increase. So the mean will increase, and let's say that just to plug in some number here, let's say that the third friend had high score of 200. So if we take into consideration the first high score of Adam, which is 250, then we have 180 plus 200 plus 220 plus 250 divided by 4. 1, 2, 3, 4 data points divided by 4, which gives us a mean of 180 plus 200 plus 220 plus 250. 8 plus 2 is 10, 10 plus 5 is 15, 2 plus 2 here, and 6, so it's 850 over 4. 850 divided by 4, 4 goes into 8 2 times, 2 times 4 is 8, we have no remainder. 4 goes into 5 one time. Remainder 1, bring down to 0, so 4 goes into 10 2 times. And 2 times 4 is 8, we have a remainder of 2. So it's 212 and 2 fourths, or 212.5. 212.5 is the mean if we take into consideration Adam's first high score. But if we take Adam's new high score, which is 290, so the mean will increase from 212.5 to 180 plus 200 plus 220 plus Adam's new high score, which is 290 divided by 4. Okay, so 180 plus 200 plus 220 plus 290. 8 plus 2 is 10, 10 plus 9 is 19, and here we have 6 plus 2 is 8, so we have 890 divided by 4, 890 divided by 4, 4 goes into 8 2 times 4 is 8, we have no remainder, we're down to 9, 4 goes into 9, 2 times 4 is 8, subtract, a remainder of 1, bring down to 0, and 4 goes into 10 2 times 4 is 8, we have a remainder of 2, so the answer is 222 and 2/4, which is 232.5. So we went from 212.5, we went up to 222.5. Okay, so the mean has increased by 10 points from 212.5 to 222.5. Let's see what happened to the median. So if we take into consideration Adam's first high score, which is 250, then the median is the mean of these two numbers, which is 210. This is the first median when we take into consideration this high score. And when we take into consideration the 290, so we have 180, 200, 220, and 290. So the median will not change. Okay. The median will stay the same. Let's see. Okay, the mean will increase, the median will stay the same. But let's see if it happens every time, because let's try a different number. Okay, let's say 180 and 220 and 250, and let's say the third is between these two numbers. Let's say that the third is closer to 180. Let's say that the third is also 180. Okay, so we have two friends with the same score of 180, and the third has a score of 220. And now we shift so to begin with, the median will be the mean of these two numbers, and the mean of 180 and 220 is 200. And if we shift 250 to the right, okay, it's still 200, so the median does not change. Okay, the mean will increase, the median will stay the same. Good. Okay, so in the next video, I will do this practice, interquartile range, and I will see you in the next video.